Okay, so Unit 6 was statistics, and to do number 35, I'm going to draw a normal distribution, and I'm going to label it well. So the mean is 14 days, and then every 2 days is a standard deviation. And then we can also put the percent in. You can use your formula sheet for this. Okay, so what percent is between 12 and 16 days? That is going to be 34 plus 34, so 68%. Greater than 18 days, we're going to add 2.35 and 0.15. That's greater than 18 here. Between 14 and 20, well, because 14 was the mean, I know that's going to be, well, it's going to be 50% minus 0.15, or you could add up the 34, the 13.5, and the 2.35. I get 49.85%. Less than 12 days, so I'll add up those percents. And if a particular insect lived for 24 days, does it live unusually long? Yes, because that is more than 3 standard deviations above the mean. Say yes, 24 days is greater than 3 standard deviations above the mean. You could also, for part E, calculate a z-score. So the z-score would be 24 days minus the mean divided by the standard deviation, and that's 5. 5 standard deviations is way above the mean, so that is an unusually long time. Okay, so looking at the graphs A and B, B has a greater standard deviation because it's more spread out. So the standard deviation of B is greater than the standard deviation of A. The means, okay, so the mean of B is at 21, the mean of A is at 15, so the mean of B is also greater than the mean of A. Which statement is true about normal distributions? The graph has a vertical line of symmetry at the mean. That is correct. There is one mode, and it is the same as mean and median. That is correct. 68% of the data is within 1 standard deviation. That is correct on both sides. And then a data with a z-score of 3 is further than a data with a z-score of -2. So this just means 3 to the right. And the -2 means 2 to the left of the mean, so that is correct as well. So to compare these stores, I'm going to calculate z-scores for both. So we've got Goldie's. So their z-score is 25.9 minus 22.6 over the standard deviation of 2.2, and that gives us a z-score of 1.5. And then doing the same for Ahmed's. 17.9 minus can't read that now. 15.1 over 1.4 gives that a z-score of 2. So the question is, who did best? So since Ahmed's, okay, first off, when it says justify, don't just leave the numbers and say Ahmed's. You have to say why. So I'm going to say Ahmed's because his z-score is further from the mean of his city, Milwaukee. Whereas Goldie's, she's closer to the mean, so Ahmed did better. Okay, so now we're going to fire the manager of the store who did worse. So let's figure out who did worse. We've got Jose's and Jamal's. I'm going to calculate z-scores again. So it's the data minus the mean over the standard deviation. So Jose's is negative 3.365, and Jamal's is negative 3.95. So that means that the manager at Jamal's store is going to be laid off or fired because their sales are further in the negative direction, so to the left of the mean, meaning they did worse. Okay, and lastly for number 40, these percents are coming again from a normal distribution. So we could draw it if we wanted. And then if Bob's score was better than 84%, so let me put my percents in again. Oops, that's in the wrong spot. Okay, so better than 84%. Well, here's 50. So here's 84. So his score was at least 29. And Sally's score is better than 2.5%. So here's 2.5. So her score was a 23.